Step 3 for solving for a truss is just drawing a quick rough draft free body diagram. And I say rough draft, so we're going to start writing out my joints here. We got A here, we got B up here. I say rough draft because the forces, the direction of the forces we could find out later change, but we're going to assume that we know most of the directional forces, and therefore which members will be under compression and which ones will be under tension at this point. And if we're wrong, we'll just get a negative answer when we don't expect to, and we can clearly change the direction of the force in our final draft answer later on. But okay, let's go ahead and start labeling the forces applied here. So we've got D, we've got 500 pounds going down, for example. All right, we solve for a reactionary force at joint C in the Y direction of upward force at joint C of 150 pounds. So what else do we know? We also know we got an upward force at joint A of 350 pounds, or reactionary force at joint A in the Y direction. And we've got a reactionary force at joint A in the X direction of 0 pounds, whopping 0 pounds. But with this information, we really have everything else we need to solve for the directional forces in our free body diagram here. So for example, member BD. Member BD has to be going upward. It has to, because, or the vector force within BD, I should say, at joint D, it has to be going upward at joint D because it has to cancel out this downward force. So this would be member BD here, or vector BD, pulling upward at joint D. And if it's pulling D upward, it has to pull B downward to cancel itself out within the member. And if it's if it's pulling our joints together, we can say that that member is under tension. And so what else do we know? I don't like to do joint A because we got rightwards and leftwards and upwards and downwards. We got multiple forces here. I like to start at the roller joint. And so, usually anyway, if you look over here, well, we've got a upward force of 150 pounds. Well, we need a downward force canceling that out. But remember, DC is incapable of providing a downward force because it's going completely in the X direction. So the only thing that's slightly going in the Y direction is BC. Therefore, it has to be going down, and if it's going down, clearly it has to be going down to the right because that's the angle of the member. So if it's going down to the right to cancel that out, that means at joint B it has to be going up and to the left to cancel itself out. That means this vector BC in member BC is under compression. And now we see BC is pushing joint C to the right. We need a force to cancel that out as well. Well, that's just going to be member DC or member CD. It doesn't really matter what you name it. That's pulling it to the left, canceling out this X component of BC at joint C. I'm just going to call it DC, but again, you can call it CD if you want to be alphabetically correct. But if DC is being pulled to the left at joint C, it has to be pulled to the right at joint D to cancel itself out. That means this joint is under tension. And if we look, joint D is being pulled to the right, so we need a leftward force on joint D, and that would be member AD. It's the only thing that could really be applying any kind of force pulling on joint D, so cancel out that rightward force. And if it's being pulled to the left here, it has to be pulled to the right at A, canceling it out, and it's being pulled inward as well, so we can say that that is tension, obviously. And I always like saving our pin joint for last, drawing our free body diagram, but it's pretty obvious. Hopefully it's pretty intuitive. We've got a rightward force at AD, and we got an upward force of 150 pounds. You might say, well, we got this 0 pounds here. So, but sometimes you'll have a force here pulling right or left. So I don't like using our AD. I like using our reactionary force, but you can use this as well. It's pretty obvious that I have to cancel out both of these, and I've got a member that just so happens can cancel out both of these. It would be going down and to the left. It would cancel out our upward force and our rightward force, and that would be member AB, providing a vector we will call AB, keep it simple, and that is clearly under compression because it's pushing out at A, and it would clearly have to push outward at B as well. And so all we really have left to do is to solve for these 5 members vector forces.